Good afternoon. I'm going to do a mathematics paper 1 of May and June 2023. In this video, you will only see question 1. Question 1.1. Solve for x. Here we have a quadratic equation. When you have a quadratic equation, you always need to think equation equal to 0, because then you'll have it in standard form. When you have it in standard form, you can factorize it. This is a trinomial, so when we factorize it, we need to look at the last term. When we look at the last term, we need to get factors of 12 that when you add them together should give you 7. So in this case, we will use 3 and 4. So we'll have a 3 there and a 4 there. The plus sign tells you that your signs need to be the same. Because my middle term is a negative, I'm giving each bracket a negative. From here, we have one term equal to 0, so I can take each bracket and give them a 0, or x minus 4 equals 0. So I have my final answer of x is equal to 3, or x is equal to 4. For 1.1.2, this bracket is giving you an indication what to do. Here it tells you to use your quadratic formula, which is located on your formula page. But before we can do that, this is not yet in standard form. We need to expand the bracket as well as take over the 1. When we take the x inside the bracket, we'll have x times 3x, which is 3x squared, plus x times 5, which is 5x. Taking over the 1, we'll have negative 1 equals to 0. Now, if you think standard form being ax squared plus bx plus c equals 0, it will give you 3 values. A, which is equal to 3, b, which is equal to 5, and c, which is equal to negative 1. And then from your formula page, you'll get the following formula. X is equal to negative b plus minus square root b squared minus 4ac over 2a. From here, I'm going to substitute in the values. I have negative, and then my b value being 5 plus minus square root 5 squared minus 4 times 3 times 1, well, negative 1, divided by 2 times 3. From here, you can plug it into your calculator and then remember to round it off to 2 decimal places. So you'll have x is equal to 0,18, or x is equal to negative 1,85. Question 1.1.3. Here we have an inequality. I'm going to make use of a sketch to make sure that my notations are correct. If I take over the negative 2x and the positive 15, I will have it in standard form. So it will be x squared plus 2x minus 15 is less than 0. Here I'm going to factorize my trinomial, still making it less than 0. For the factors of 15, if you subtract them to become 2, you're going to use 3 and 5. Because of the negative sign, your signs need to be different. And because the middle term is a positive, my higher number gets the positive. So I have my critical values being x is equal to 3 or x is equal to negative 5. From here, I'm going to draw a sketch. You will notice I have the negative 5 and the 3. Because of that less than 0, meaning I need to look for negative values, you will notice that will be in between the negative 5 and the 3. That's why my x will be in the middle. So I'll have my negative 5 over here and my 3 over there. So x is less than 3 but greater than negative 5. Question 1.1.4. This is an equation with a surd. Always remember to get this surd alone. When you get it alone, you can square both sides. When you square both sides, you get rid of the surd, but then be careful. The x minus 1 in brackets is a trinomial. So yes, you get 2 bracket 1 minus x, close the bracket alone, but to expand x minus 1 squared, I'm going to use a short method. X times x is x squared. X times negative 1 is negative 1x times 2, negative 2x. Then we have negative 1 times negative 1, which is plus 1. Then we're going to expand the left-hand side. We'll have 2 times 1, which is 2. 2 times negative x, which is negative 2x. Equates to x squared minus 2x plus 1. Here we have a quadratic equation again, so I'm going to get everything onto one side. So I have my x squared minus 2x plus 1 minus 2 plus 2x equals 0. Calculating the like terms, the negative 2x plus 2x falls away, and 1 minus 2 becomes a negative 1 equals 0. From here we can have x squared equals to 1. Can square root both sides. When you square root both sides, remember there's a positive and a negative in front of the square root. So you'll have x is equal to 1 or x is equal to negative 1. Please remember to always see if the negative 1 will get you to the right answer as well as the 1. In this case, it's only the 1 that is relevant. The other one is not applicable. For the next one, which is 1.2, they ask you to solve x and y simultaneously. Now I'm going to start by getting 3 to the power of x plus y equals to 27. I'm going to see if I can get the 27 to also have a base 3, which you can use your calculator as fact button. If you type it in your calculator, the 27, and pressing the fact button, it will give you 3 to the power of 3. Because my bases are the same, I can drop them, so I'm working with x plus y is equal to 3. Now I'm going to get one variable alone, which is x. So I have 3 minus y left. Now, from here, I can substitute everywhere I see an x in the second equation. So that will be bracket 3 minus y squared plus y squared equals 17. Now I'm going to expand the bracket again using the short method. 3 times 3 is 9. 3 times negative y is negative 3y times 2, which is negative 6y. Negative y times negative y is plus y squared. And taking over the 17, we'll have negative 17 equals 0. Again, adding the like terms, we'll have 2y squared minus 6y, and 9 minus 17 is negative 8. Here I can divide by 2 everywhere, so I'll have y squared minus 3y minus 4 equals 0. If I want to factorize this trinomial, I'm going to use the factors 1 and 4, because that, if I subtract them, will give me 3. So I have a y and a y, a 1 and a 4. Again, because of that negative, the signs needs to be different. The middle term tells me that the bigger number needs to be a negative. So y plus 1, y minus 4 equals 0. Again, from here you can get the answers. Y is equal to negative 1 or y is equal to 4. From here, I'm going to substitute the y values back into that equation using my calculator. So it will be like x is equal to 3 minus 1, or x is equal to 3 minus 4. So x is equal to 4, or x is equal to negative 1. 1.3. Here we have a little bit of a higher order question. To determine without the use of a calculator the value of the following, the key here would to first rationalize the denominator. So just doing one of them, two of them, meaning for example if I go 1 over square root 1 plus square root 2, if I want to get those surds to the top, I'm going to times with square root 1 minus square root 2. So this will be like difference of 2 squares. You can do it again with the following. So you'll have your 1 over square root 2 plus square root 3 times square root 2 minus square root 3 over square root 2 minus square root 3 plus all the way to the end where you have your 1 over square root 99 plus square root 100. Again, rationalizing the denominator, timesing by square root 99 minus square root 100 over square root 99 minus square root 100. You will have the following. You will have your square root 1, which is just 1 minus square root 2 if you times those together. At the bottom, you'll have square root 1 times square root 1, which is 1, minus square root 2 times square root 2, which is 2. Plus, doing exactly the same thing, timesing the numerator with the numerator, you'll find that it will be square root 2 minus square root 3 over 2 minus 3. And then for the last one, if you times the numerator with the numerator and the denominator with the denominator, you will have square root 99 minus square root 100, which is just 10, over 99 minus 100. So you'll notice the pattern shows that your denominator keeps becoming a negative 1. So in the end, your signs basically will change to negative 1 plus square root 2 minus square root 2 plus square root 3. And then if you continue with this sequence, you would have had a minus square root 3 plus 2, continuing, minus square root 99 plus 10. Then you would have noticed that your square root 2 minus square root 2 becomes 0. Your square root 3 minus square root 3 becomes 0. And although you don't see it, but the plus 2 and the minus square root 99 also falls away in this sequence. So you're left with negative 1 plus 10. So the answer is 9. And that's the end of question 1.